let us go ahead and get ourselves going again. What we are going to do is just continue with the whole idea of pulling values out of the model. We have so far been looking at the notion of taking window elements, which are located in a Revit model, and pulling out their X locations and going through doing some computations based on that. And where we got to was really, we grabbed the window elements by saying all the family, which are the family type, which is a specific type of window, and we got all the instances. Then said for these, give you the location and then the point X or point Y of that location. Again, we can pull whatever we want. I'm just going with X because my windows vary in the X direction. Then there's this whole notion of just using a sine wave to go through and compute something. In my case, what I was suggesting was I was going to compute the sill height, the base of the window, and have it move up and down. Or we can compute the height. We have a lot of things we can compute the window. So let us go through and just kind of look at this, because this should actually look very familiar. Go back over in to Revit, or to Dynamo, and take a look. So I had all those X values. They're kind of hanging around over here. Those X values are kind of okay, going everywhere from the negatives to the positives. Looks like my origin is somewhere in about the middle. What I'm going to do is compute all those X values first. Okay. What am I going to do? Oh, I'm going to do something called the wave frequency. I'm going to multiply by that. That's just going to either pull things in tight or spread things out, depending upon what number I put in there. If I put a number greater than 1, it'll spread out the wave. If I put in a number less than 1, it'll pull the wave in tight. Either way. I'll take that and compute those into, treat them as radians. That'll convert into degrees. Compute the sine, then multiply it by an amplification factor. And finally, just add in a base height, because I don't want the base of the windows to go below 0. Okay. Yes?
If you had multiple different types of window sizes all in a row, and you wanted to do the same sill height computation as what we're doing now, how would you select both of those types?
A very good question. A very good question. Let's go back in over here and see if we can sort of play with that. So, for example, if, for example, that wasn't 12 by 48, but it was really, 16 by 72 or something like that, and that one's a 16 by 72. Okay. You are rightly suspecting that over here, that is not going to pull them out anymore. That's just going to only be getting the 12 by 48. So what I need to do is just grab that, copy and paste that. I'm going to grab the other type. I'm going to zoom that in a little bit closer so you can see it. Sending back 16 by 72. Okay, that should now have a subset. That should only be about 2 windows in there right now. Super. I got all elements of this. I've got all elements of that. I got basically 2 lists. Okay, and what I like to do is put those 2 lists together. So let's see what it is, because you're in the right territory, but I always have trouble remembering which one it is.
It's join, right?
I think it's a join. Excellent. Okay, so what I'm going to do is just basically take 2 lists, grab that list, grab this list, and take that combined list. Let's actually just sort of run it and see. I got a bunch of 16 by 72s and the 16 by 48s. Super. And then pull them down over as those being the family instances. Fortunately, since all we're doing is grabbing the X values, the order doesn't really matter. Yeah, because they can sort of be in any order. So that's not going to stop us.
Wait, what do you mean by that?
Oh, the fact that the 16 by 72s are at items 0 and 1, and the others are 2 through 10, it's order independent, because what I'm really using to create the wave is the X value. And the X value stands, whether you're at the front of the list or the back of the list, because it's actually just based on the geometric location. Okay. So I pull all those values in here. I have all sorts of different height values in here. The key as you look at the height values is you just want to make sure that the way you've set this up, that all of your heights are greater than 0. Because if any of your heights are less than 0, just Revit will complain. Revit doesn't like to go ahead and put still heights in that are less than 0. So I'm going to take those over and I'm going to do something. In terms of setting the values, I have a whole series of different height values, still height values. I have a whole series of different elements. I want to get those two together. So it's, again, element set parameter by name. What I'll do is, let's get that list of all the elements across. Let's get the sill heights. Should be the same whether I take it out of either of these functions. And you can sort of see what's going on back over there in the preview. That's just showing me the points. Super. They're not looking too awfully bad right now. If you want to play around a little bit, and let's just play around with the function a little bit. If I sort of amp up the amplitude, you can sort of see I can get up to a pretty good height. I'm eventually going to get to some point where something's going to break, because Revit's just not going to be able to sort of generate them. Looks like my base height is 7. I think if I exceeded like 8 or 9 or something like that, it would just start getting some 0 values. Let's see. Okay, in terms of the frequency, let's play with that slider too. That's the one, if you make the frequency, looks like lesser, it's smoothing it out, there are fewer troughs. If I make the frequency factor higher, I'm getting a lot more troughs in there. Although, as I get too high, it may be hard to see the pattern, just because I don't have enough points so you guys can see the pattern very well.
If I wanted to do something like this, like with a wall, like, can I do this with Dynamo as well?
Yeah.
Oh.
We're going to go ahead and, be able to kind of create some curvy wall and then place a wall on top of that.
Oh, okay.
Yeah. So let's go on back. Okay, as I'm playing around with all these, if you go back over here, you'll see that the heights are sort of matching over there.
Did you, when you created the frequency slider, you set the max to 1 because
It was just sort of my rough sense about how big a factor you want to kind of throw it, but it's really any number you want to. It's ultimately getting down to just sort of what looks good and appropriate to you. So again, if I'm over here, the frequencies are the weirdest ones to sort of understand. The higher the frequency, the more troughs I'm trying to get in there. But actually what happens then is you sort of see on the windows, just because of the notion of where the spacing is relative to the wave, it almost looks a little bit more random. That is a sine wave, but that may be something you want. You know there's a sine wave in there, but it may not be entirely obvious. A lot of people just look at it and say, ooh, that's a really interesting pattern, or something like that. Again, I've been doing all these things with sine waves, but realize there's nothing special about sine waves. There's any number of other mathematical functions we could be using too. It's just sine waves are sort of really easy to see, and spot and stuff like that. So you can really be almost any kind of math you want. Let us go ahead. Let's pause there for a second. Is that sort of making sense? Yes.
So when we're getting the locations, we're getting the global coordinates.
Correct.
Can we get the local ones?
Oh, like local on the wall?
Yeah. Because like if the wall is slotted by itself, I don't want it to like go the local coordinates and put a sign right on it.
That's an interesting. The answer's got to be yes. I don't know what the function is right offhand, but the answer's got to be yes. We might have to do some funny transform where we take the global coordinates and we figure out what the baseline of the wall is, and we try to we do a little math to figure out what that would be. Okay. The answer's got to be yes. That's a good question. Yes?
I think I had a similar question in terms of, do we know what the base of the wall is? Because I think I'm already going, my windows are below the base of the wall.
Oh, well, in this case, okay, oh, that's interesting.
Because I set my wave base height to be really low, and then it ends up putting windows outside the wall.
Let's try something. Let's just sort of see something, okay, in that same spirit. We'll do the old, we're gonna select, and let's select an element, edge. I can select an edge. Let's try a couple different things. Let me say select element. All types, select model element. Let's try that as a one thing. I'm also going to try select edge, just because I think that might be an interesting one too. Okay, so these are the ones where we're explicitly going to go through, and let me select either the wall. Super. Hey, come on in. We can also select just that lower edge of the wall. And let us see what it is. They're both elements, stuff like that. Let me sort of think about the location. Element location, something like that. Where did it go? Family instance location? No, I'll go with the location. Site location. You have the element. That's interesting. I'm trying to figure out which function it will be because it's not a family instance. Element ID. The name of the level it's on. Wall type. I can tell you what type of wall it is. Reference point. That's interesting. This is interesting. The bounding box of the element. Let's see what that one will actually do for you. What this is going to return for you is, they're actually, well, I'll do the watch for you. There's a box that would be drawn around the wall. I'm just trying to think about what the best way to get that is. So if you can picture a box that goes from minus 2550 up to 34620, yeah, that is sort of the outer bounds of that. But again, it's not exactly what you have in mind. I don't know. I'm gonna keep on playing around and see if we come up with a good function for doing that. Ultimately, it's all just a lot of data values in a database, so we can sort of play around with any of them. Okay, let us go ahead and try something a little bit different though, because setting these sill heights is kind of a cool thing in terms of doing that. We could also go ahead and set the head height. That'd be another parameter. Again, that will give you a very similar result, but you can sort of tell what you can get at just by just whatever parameters are out here. Okay. You can also, if you want to, go through and set the parameters, which are the type parameters. These are instance parameters. So don't forget, you can also go through and set type parameters. Type parameters don't make as much sense for what we're doing right here, though, because since we're trying to adjust every individual window, if you set the type parameters, it would try to say everything with the same type would have the same value, which would then be sort of an inconsistency in your logic. Okay. But we can go ahead and play with that. Let's go ahead and think about what we can do with that, though. When we talk about there being parametric design, there are all sorts of parameters that are available in different objects. So for this little window, fixed window, 12 by 48, it has different parameters. It has the height, it has the head height, it has the length of the width, or the width and the height of the window, stuff like that. Those all just kind of come out of Revit families. And where this starts to get interesting, though, is you may want to go through and start adapting the types of parameters that are available, so you get more kind of bang out of it. You get sort of more function out of it. And that's what I want to show you next. We'll finish up with that today. When it comes time to create Revit families, you can go through and actually adjust them. We could add all sorts of things, or basically make different parameters available to us. We can make the materiality, we can make the visibility of individual elements, we can add parts to it, we can do all sorts of different things. And the example that I'll show you next really has to do with, if you got a window like that, this nice little 12 by 48 window, and that's kind of okay, and you're thinking that, on the south side of your building, you might want to put some shelves on it, or you might want to put some fins on it, or something like that, that will have a smart distance that's somehow calculated. But if you want to be like the Y2E2 building or some of the buildings in our quad here, you have these fins and shelves. You could go ahead and add in all the fins and shelves individually in Revit, but then you have that overhead. Every time I move the window, I gotta move the shelf, and it's just kind of very cumbersome to have those as two separate elements. Where if you really think of the shelf as being a part of the window itself, and if it moves, the shelf will move with it, or we can parametrically control where the shelf is on the window, gives you much more flexibility. Okay, so that's what this next little piece is going to be all about. It's really how we can set up a family like that and then adjust it. So I'm going to go back over to Revit and give you a little bit on creating Revit families. And depending on when you took A, like we did this once, we didn't do it this last time as much. We sort of like kind of went very quickly through it right on the last day, but let me kind of show you the basic theory. So you got this sort of window here. It's a fixed 12 by 48, and it's actually a family. It's a family that's defined out there. If you say edit the family, you can actually see how it's defined. So this is like this little 3D element. It's a little bit hard to tell what's going on when we look at it this way. But if I look at it in terms of like the elevation views, you actually see there's all sorts of different parameters that define its shape and width and things like that. You can see here this default sill height, the height being 4 right now is a parameter that can be changed. There's all sorts of things about the framing, the sash, the glass, and how that's all kind of layered in there. But we can spend a lot of time just talking about just putting together things like this. There's the height, you can sort of see it there. On the left and the right sides, you don't see too much in there. That's just kind of where the glass plane is, front to back, things like that. But if you want to start adapting these, we can. Let me show you what we're going to get to in this, and then we'll back off to it. What I really wanted to do is actually go through and create a window, okay, that had more parts to it. So under 3.3, you'll find window with shelf and fins, which is sort of a new improved version of that. Okay, so it all starts with just where we were. There's this sort of fixed window that has an adjustable size. Okay, what I wanted to do is basically, add a shelf to it. And a shelf is really just a nice horizontal surface. It's like a horizontal surface. It has a depth, it has a width, and I won't go into the detail of going through and creating it just so we can show you how we use it today. We'll talk about it some more next time. But I want to take that shelf and put it on the window. So if I combine the two together, I get something that looks like this. So I can pop it around. There it is. A little window shelf up there. And I'll show you this more next time, so I just want to get through how you can use it first. But if we would like, for example, that shelf to adapt itself so if the window got thicker or wider, it became wider. If the window got shorter, it followed the window, all those different things, we could. So in this one, let's just give it a little test. If I look at the properties, for example, if I go to a 12 by 24 window, looks like the shelf is doing about the right thing. Let's do a very big window. The shelf appears to be doing the right things. Actually, one thing we haven't really played with very much, though, there is this notion of shelf depth. Okay, shelf depth is out there. So if I wanted to go through and make the shelf 2 feet deep, I could make it, or 4 feet deep. I can make that, I can do all these different things. So in the little files in here, and again, we'll show you how we create all these next time, I have this like window that has a shelf associated with it. Okay? If you really want to kind of think ahead, I actually have another version of it that goes one step further. If you go all the way down to shelf and fins, it's a window that has basically a shelf on the top as well as fins on the side. So you get all sorts of, it's the universal window. It can kind of handle almost any different situation there. So again, let's just look at the parameters that are available to us. If I go to the window itself, oops, the family types, you'll see the shelf thickness, the shelf depth are different things. I go through and adjust those things. I have the fin depth. So these are all different parameters I've set up to allow me to go through and vary that. And that can kind of really be very, very useful. Another sort of property that's a very good one to have, though, is just really whether there will be a shelf or a fin at all. And what we can actually do is set up parameters that are yes, no parameters. Parameters that have checkboxes to say either yes, you have it, or no, you don't. It's either true or false that you have a fin, true or false that you have a shelf. Okay, so again, we'll show you how you go through and create these next time. But let's just go ahead and think about using it. So I got this sort of family. If I'd like to use that as opposed to working with the standard one, I'll just import it and say we're going to place that instead. Then what are we going to do? We're going to go through and just control the parameters, and we can set up whatever formulas we want, either maybe changing the shelf depth or maybe changing the shelf visibility, just based on something about the calculations, and have it respond pretty quickly. So here's how we're going to do that. If you do open up, why don't you do this? Open up the Windows 6 fixed with shelf and fins. Open that, and what we're going to do is load it into the project. We need to get it into the Revit project so we have it available to work with. So see if you can get that one open, just the one. This is the one that has the shelf and the fins, kind of the tail end of the exercise. I'm going to say let's load it into project, and with any luck, somewhere out there you'll still see example 3.2 open. If it's not, open 3.2 and we'll insert it. Either way, you know, it's all about the same. See if you can bring it in there.
If it already exists, do you overwrite?
Oh yes, that'd be fine. If I already have it loaded in there, then I'm ahead of the game. Or you're ahead of the game. Okay, and how about this? Just to get ourselves going, if it does already exist, and I think it may already exist in there. See what I got in there? I do have that Windows 6 in there. Okay, if you want to change them all so they are that type, go ahead and just grab them all. I'll do a little filter, so I'm only getting all the windows. I'm just going to change them all to be that fixed window with a shelf and fins. I'll make them 16 by 48, make them a little bigger. So you see right now they have all these little hoods on them. They have the shelf and they have the fins. If I wanted to go through and start changing that, I could again change it manually in Revit because that's what we're used to doing. We can go through and grab all those and say, you know, for the fins, well, in fact, if I don't want them to have fins at all, I'll just turn off the fins. I'll just turn them off as parameters. And when I say apply, those will go away. Okay, but the more parametric control you can give your objects, the more flexibility you have. Okay, so I got that in there, but what I want to do is actually use my little bit of logic to go through and do something interesting here. So I've got all these different little windows hanging around in here. That's super. I'm going to go ahead and adjust my logic so it uses these windows as opposed to the other windows. And how about this? And rather than going through and just kind of having them all have the same shelf depth, what if we had the shelf depth somehow be related to the height? You know, somehow there's some, just relationship between that. Actually, if we played around with this, we'd probably want to make it related to the kind of window height, but we'll play with this for now. So going back into that same logic, the big thing is I am just going to go switching on over here, and instead of saying that it's going to be the fixed 24 by 36, I got to find that fixed with shelf. What's that thing actually called? Window 6, fixed with shelf. So, did I make them all 16 by 48? I think that was it. I got a bunch in there. Super. Okay, so I got a list of all of these now. They're all kind of hanging around with whatever they're doing. See if you can grab that list of all the new improved ones. So again, I'll even get rid of this part up here because I don't really, well, it's kind of sitting there empty right now. But I should be seeing a list of all these 16 by 48s.
How did you make all the windows that size again?
Oh, what I did was back over in Revit. I just grabbed all the windows and then just chose them in the type selector. Okay, and that superseded them all. For you, it might say multiple set types because it's a mixture right now. And even over here, what do I want to do over here? I'll grab all those. Just so we're starting out. Yeah, something even. I'll just make them all 5, just so they're all kind of looking fairly uniform. Oh, but Dynamo's working in the background, so I put them back up again. It's because it's running automatically. Okay, so see if you can grab all those guys. Super, you have all these different windows. The family instance, that's all the same. The point X, that's all the same. All your logic of your calculations stayed the same. That hasn't really changed. So, again, I'm not using this one anymore. I really just have a single one in there. What's going on here? I'm trying to be quick and I may have messed it up. I think I just messed it up. Let's pull it down to there. Oh, I know what I did. Undo a few. I took out too much. That's the one I wanted. Okay, I'll leave it alone. Okay, so I got my values, they're looking pretty good. What I'm gonna do is take all those different values and say, hey, in addition to sort of setting the sill height, because the sill height is okay, what if I actually went through and also adjusted the shelf depth? So again, what I'm gonna be looking at is, for each of these different guys over here, I have a parameter called shelf depth. If I want to do something similar, I can go through and copy this. I'm going to call it, change it from sill height to basically be shelf depth. If I can spell it properly. Zoom that up so I can actually see what I'm spelling.
It looks so silly.
Okay, and then like it's trying to do something in here. There we go. Odd tongue sticking out. Okay. Now again, this may not be the relationship you wanted to have. We could go through and do sort of one over the, we could create all sorts of different relationships in here. We could sort of say there's a base depth the shelves would be, and kind of vary that, and have them vary to more of a sine wave. But yeah, anything we really want to have happen. We could also go ahead and, for example, like have things turn on or turn off. For example, I'll say that next time. We'll show you, there's an example of basically we can start using if conditions to say, in cases where this is below a certain threshold, have one thing happen. In cases where it's above another threshold, have something else happen instead. We're going to learn to basically take these lists of elements and sort them into categories where either you meet the condition or you don't meet the condition, and based upon where you were relative to that condition, either make something happen or not. Okay, we'll let you go. The final thing that we're gonna talk about, where we'll go next time, is we are going to say, great, all these kind of just parametric families that look like this are pretty good to work with, but what if we actually wanted to work with, again, just more the adaptive components? Okay, things that involve more than a single point, and can we use geometry to start sort of adjusting and placing them? And what we're going to do is start seeing that there are similar sorts of elements, like the little Revit families that we have that I just added a little shelf and fin to, that define kind of as single placement points, but there are also things that look like this, where, well, that's a very simple one. You'll see there's basically 3 placement points, and if we wanted to put a little squarish truss in there, we have point 1, point 2, and point 3, and if we feed it 3 points, we can adapt something to kind of make it meet that geometry. Let me switch to one that's a little more interesting. This is another little 3-point truss. This one looks a little bit different though. If you take a look at that one, this still has 3 points, but what's happening is we have like a little tube section that goes through the 3 points, as well as some little lines that connect them all together. They kind of like a round truss that has like wires connected together, something like that. So what we'll do next time is we'll look at, for the standard Revit families, how we add those things and customize them, as well as how we create these sorts of adaptive components. Now we're going to just do the same thing. We're going to use a little geometry to go through and just figure out where some points should be and then connect the points together. Cool. Okay, let us adjourn for today.